Okay, guys, we are looking at lesson 8.7, and I've got my Bluetooth headset connected here, so we'll see if we'll avoid some of these random scratchy noises, right, when we got Michael Greco online now looking at this document. So we are, let me go to my notes. We are looking at lesson 8.7. And this has to do with secant lines. Now, we've been talking a little bit about secant lines, right? Secant lines are lines that cross through the circle. So, for example, this line would be a secant line, okay? And this one is also a secant line. So this now is an angle outside the circle made by two secant lines. Now, remember, if you're just an angle on the circle, right, this is called an inscribed angle. It is half the measure of this arc, right? So we know it probably has to do something with half and how this angle is related to these arcs, right? So once you've gone outside the circle now, right? Once you've made that angle outside the circle, now you've got this other arc involved, right? So I've moved from an inscribed angle now to an angle outside the circle. And so now we have to somehow get this arc involved as well as this arc, okay? And the formula works out pretty nicely, which is given right up here. The bigger arc minus the smaller arc divided by 2, basically, is the measure of that angle, okay? So I'll do this one real quick. X is going to be half of 125 minus 27, okay? So that's pretty easy. 1/2 of that's 98. That's 2 less than a hundo, right? And X is going to be 49 degrees. Okay, these are all degrees. Okay. Now we have a secant and a tangent. So we have one line that is a secant, and the other line happens to be a tangent. Okay. But the same formula is going to hold. But first, I've got a joke for you. Okay. Why do you always follow your instinct when doing trigonometry? Because you might have secant thoughts and go off on a tangent. Okay, that's a little bit of a play on words. Secant sounds a little bit like secret, right? So why do you always follow your instinct when doing trigonometry? Because you might have secant thoughts and go off on a tangent. Okay. Okay, anyway, let's get to the work at hand here. We've got this angle has cut off two arcs again, this green arc, and let's put this one in a little bit of kind of a colored, weird color here. Okay, those two arcs. Notice that 40-degree arc that's marked is not part of my two arcs that are cut off that are the outer and inner arc of that angle. Okay, and the way you want to think about that is this angle, if you kind of scope the measurement of that angle, like when you're measuring that angle with a protractor or something, you're measuring between the orange and the blue line. Those are the two arcs that are covered by that angle. This 40-degree arc is not covered at all, right? So what we want to look at is this arc here, which is 200, and this arc here, which we don't know. Let me call that y, okay? So we first got to find out y. Now we know y plus 40 plus 200 equals 360, right? So y plus 240 equals 360, so y equals 120. Okay, if you had 240 over here and subtract it from both sides, you're going to get 120. So that in there is 120. Okay, I can mark that 120 degrees in there. Okay, now that basically now allows me to follow the formula. X is 1/2 the measure of the outer arc, which is 200, minus the inner arc is 120. This all ends up being 80. Half of 80 is 40 degrees. Okay. Okay. Now, what happens when we have two tangents? Okay. Two tangents. Now, another joke for you. Why was the math lecture so long? Well, the professor kept going off on a tangent. Okay, so make sure, when you got a math teacher going off on tangents, right? Things don't go too long. Okay, you might also say that people like me that go off on tangents are so annoying, right? You're just trying to get through the lecture, you're trying to take your notes. But people that go off on tangents are so annoying. You might tell me, just learn to stay in the circle, okay? Just stay in your lane, stay in the circle. Okay. At any rate, we've got two tangents here, and there's a unique situation that happens. When you cut off the two arcs, you're going to notice that the outer arc is over here, right? And the inner arc is right here, right? And together they make 360. So if you know one of them, the other one can easily be found. Let me call this arc Y. 360 subtracted from 117 is going to give you Y. So Y is going to be 253, I believe, right? So if that is the blue arc, okay, and the same formula holds, I'm able to find X. I'm able to find X by taking 1/2 the measure of 253 minus 117, which is 1/2 of, what is that there? 126, is it? I believe. 126. These are all degrees. So X is 1/2 126, which is 63 degrees. Now, as an extra credit for those of you actually paying attention, 163 and 117 have a certain relationship. Add them together. Tell me what they are. Write it out by hand. What's the relationship between this arc, this inner arc, and this measure X? They both add up to what? What is that special word that we give it in math? Okay, so write it out in words. When you have an angle outside a circle formed by two tangents, right? You have an angle outside the circle formed by two tangents. That angle is what compared to the measure of the inner arc? Okay. Okay, I'm going to stop this video and go on the examples in another video.